All right, the last little part here is going to be kind of a recap of all of the bonding theories and sometimes why we need more than one to explain what we see. So bonding theories and delocalized bonding. So some molecules are best described with a combination of models and theories. Benzene, or C6H6, is represented with two resonance structures. This is something we actually did previously. This is 6 carbons, and this is a way we represent it in organic chemistry. So the double bonds can either be here, here, and here, or here, here, and here. Those are the resonance structures. Okay, so the pi bonds here are called delocalized. That means they don't have a locale, they can move. Okay, that means they spread out over the whole molecule. So instead of representing it as a double bond, double bond, double bond, what we're going to do is actually the pi bonds look kind of like this. This whole spread structure. It's not like it's just here, and just here. It's actually over the whole molecule. So those are called delocalized electrons. And that's actually explained with a combination of those theories. So all of the theories are important and they all explain different things that we observe. So as a quick review of the bonding theories, these are the ones that we need to know and be able to do. And they all have their own strengths and weaknesses, which is why we need them all. So Lewis dot structures are great because they are a qualitative prediction of the bond length and bond strength. Okay, we can draw them out. We can see them pretty easily. It's 2D. That is one of their weaknesses. They're only 2D and they don't explain the properties, why bonds form, or specific ones. Okay, now some of this also occurs in VSEPR. So VSEPR theory can predict the shape and the structure and the polarity. That's an important property. Again, though, it doesn't explain some of the properties or why the bonds form. Okay, now we get into valence with hybridization and molecular orbitals. This explains more of the properties and why the bonds form. So valence bond theory explains why they bond with orbital overlap, right? They can overlap, share electrons, all good. But this only explains some of the bonds. So then we had to add in hybridization of those atomic orbitals. This is really just an extension of valence bond theory and explains more of the molecules. We used hybridization to explain molecules that didn't easily overlap and gave some different angles. But then again, it still doesn't explain some properties like magnetism, paramagnetism, and diamagnetism, which molecular orbital theory does. It explains all of the properties. It is very quantitative. We can actually measure these. The downfall, though, of molecular orbital theory is you really can't visualize it and what those molecules look like, and it is very complex overall. Once we get into more complex molecules, molecular orbitals look crazy. So there are pros and cons to all of these, again, why we have all of them, and they're all important. So make sure when you're reading questions in this exam, you specifically read, am I talking about valence bond theory, VSEPR, molecular orbital theory? They are all different and they all bring their own things to the table.